Today we'll be looking at section 1.1 linear models. Linear models, the two equations that we'll be looking at are slope-intercept form, which is y equals mx plus b, and standard form, ax plus by equals c. Sometimes you'll hear them refer to standard form as the general form, so we'll get into that later in the section. So the first problem I kind of want to look at is this. The temperature in the desert at 6 a.m. just before sunrise was 65 degrees. The temperature rose 5 degrees every hour until it reached its maximum value at 5 p.m. Complete the table for the values for the temperature T at h hours after 6 a.m. So we got to write an equation, right? First thing, before we can turn around and look at the table. I think that's a lot easier. So at 6 a.m., that's in the beginning. So we're going to write an equation in the form of y equals mx plus b. And then this is really t equals the slope h plus b, right? The slope is m. So we're going to write it in terms of t and h. H being an input, right? So the h equals the x and the t equals the y in this. So in the beginning, before the sun came up, it was at 65 degrees. So that's an initial value, okay? So at 0 time, it was 65. Ooh, that's kind of rough looking. Let me see if I can write that a little bit neater. At 0 time, it was 65 degrees, right? So we can kind of put that as an ordered pair. That's really the y-intercept. And the temperature rose 5 degrees every hour. And if you look at that, anytime you have something that's changing per like a rate, then that's slope. So I've got the slope equals 5. So t would be 5h, t equals 5h plus 65, and the 65 happens to be the b, right? The initial value, the y-intercept, if you remember that. All right, so I'm going to teach you. You could plug these in now, 1, 2, 3, and 7 into this equation and everything, but I'm going to show you how to do that on the calculator because this is a modeling class and it's a lot easier to do it on a calculator. So I'm going to type in the equation. Let's see. Let me hop out of here. Normally your calculator comes up like this. A couple of things. Second mode will get you out of anything, okay? So let's kind of look back. It's 5h plus 65. So what we want to do is we want to type that into our calculator. So we're going to go to y equals, okay, and that's our equation there. That's where we put in any equation that we're going to evaluate. So here's 5, and then I'm going to hit this button up here. That is x t theta n. What that does is it gives me the variable x. Okay, that's going to be my inputs. Plus 65. Okay, now we're going to look at this. We're going to evaluate this in a couple of ways. We can do it as a table. So we've got the equation in. Now let's go look at it in terms of a table. And first thing we need to do is let's hit second mode, just kind of get out of that, kind of show you. You don't have to hit second mode at this point, but it's good to just kind of to take a step back when you're learning your calculator. What are the buttons that I need to hit? And in order to look at a table, I got to make sure the table is set up. So that would be second window. So if you go second window, if you look at the word above it, it says table set. And it says it's going to start at -1, right? So if we want it to start at 1, all we'd have to do is put 1, hit enter. This little triangle means delta. How is the table going to change? So we want our inputs to change by 1 hour. and then the independent and dependent. Independent is an X value, dependent is a Y value, and we'll look at that and kind of, but we'll leave it as auto. So if we look over here and go second graph, what we've got is we've got a list of X's, which represent the hours after 6 a.m. So 1 hour would be 7 a.m., 2 would be 8, 3 would be 9, so forth and so on. And we can look at the progression of the temperature. So what that does is it helps us to be able to fill out this table. Okay. Now, it also says to graph the equation. So we're going to look at it from graphing on the calculator. We know it in the beginning, it started out at 65 degrees, right? So that's an output. And then we know by 11 hours later, it's 120 degrees if it was theoretically, if it kept on getting hotter. We know it doesn't, but anyway. So what we're going to do is we're going to kind of look at some windows. Look at this. Yeah, okay. So we're going to hit window. And it has X max and X min, right? And then the XSCL means X scale. How do I want my little dashes to go up by? You can leave them at 1. You can put them at 2. Doesn't really matter. You can make it whatever you want it to be. But those little tick marks will be that value or incrementing by that value. You have Y min and Y max and Y scale. I do not touch XRES or the change or trace step. I don't do that, okay? Now, because we're talking about temperature and we're starting at 6 a.m., I am just me. I'm going to put -1 because I like to see the Y-axis, okay? And I'm going to put, I'm going to leave at X max as 10. That's 10 hours up, right? So that would be, what, 4 p.m.? So, and if we let's make it 12, and that would be a 6 a.m. to 6 p.m., right? We'll step it by 1. Now, let's look at my Y min. How hot let's look at my Y max. How hot do I think it's going to get? Well, the temperature is rising 5 degrees every hour. So if we go back and we look at our table, second graph, which gets to our table, if we look at 11 hours is 120. So if it's rising or changing 5 degrees every hour, then we know at 12 hours it'll be 125, right? So what we can do is we can go second. Well, I don't need second, sorry. Second window, just hit window period, not second window. I know that my Y max would be 125, so I'm going to make it 130, give just a little bit ahead of it, a little bit of headroom up there, and then -10 is fine, and I'll say it changes by 5. So my Y scale is going to go up 5 degrees, okay? Now we're just going to hit graph. All right, so we're starting it. There's -1, there's 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? So that's what the graph looks like. And we know that this would be 65 down here at the origin, 70, 75, 80, 85, 90, so forth. So no, sorry. Let me back up. That's 0, 0, because, hold up. Yeah, I put it as -10, my bad. I guess we could start, well, yeah, that's fine. 0, 10, 20, 30, 40, 50, 60 on up, right? No, 5, 10, 15, 20. It goes by 5. I'll get it right in a minute. So this gives you just 65, and then you can see how it goes up from there, right? So we've graphed it. Now, So we've done all this. We can figure out what this is, and we've graphed it. Let's look at the 7. How hot is it at noon? Noon would be how many hours from 6 a.m.? It'd be 6, right? So we can look very quickly. There's a couple ways. We can go second graph, which gives us our table. We can see it's 6 hours. It's 95 degrees, right? So we can go, okay, it's 90. It is 95 degrees, right? Illustrate the answer on your graph. Well, you can look at it, you know, if you have to graph it, but we can see it on the table. When will a temperature be 115 degrees? We can do this 2 ways, and I really want you to kind of look at this because this is giving you an input, find output. So this is really what we call a chug and plug, right? So the H in this was 6, right? There, 6. So we plugged 6 into our equation, right? Or we looked at our table. Now, this says, okay, output is 115. Find input, right? Which is X. And Y would be the output. Okay? So if we're looking at that, well, really that would be T and this would be H, right? So T equals what? 5H plus 65. So from a mathematical standpoint, they're saying, hey, 115 equals 5H plus 65. Find the H, right? So we can do that a couple ways. You can algebraically solve it, which is good, or you can do it on the calculator. If we do it on the calculator, we can look at a table. So we're looking at, let's see, hold up, 115. So we're looking at 10 hours, right? 10 hours from that would be what? 4 o'clock, right? So 7 be 1, 8, 9, 10. So 10H is 10 hours would be from 6 a.m. would be 4 p.m. there. Now we can also, I want to show you back here, we hit graph because that's our graph. I want to show you 115, right? It said 115. So I want to draw in Y2, I want to put the output at 115. And what that's going to do is draw me a horizontal line. And we can, once we have the horizontal line, you can look and see and come down, right? Well, our calculators are really cool. They'll solve stuff for us. So let me hit clear here and show you the key steps to do that. Second, trace. Anytime you want to do a calculation or perform a calculation on a graph, it's second trace, okay, which is calc. We want to do 5 intersection. And the really cool thing about this is all you have to do is hit enter 3 times. Okay, for linears, you can just hit it 3 times. So 1, 2, and 3. And we know that X would be 10 when the output's 115. That's 10 hours. 10 hours from 6 a.m., which would be 4 p.m., right? So this would be, the H came out to be 10, which we would say is 4 p.m. All right, so that's kind of teaching this using the calculator and doing a lot of stuff, because it may have been a while since you've done this, so I want to make sure you're good.